So we're going to look at the input systems in Unreal. We need to talk about the legacy system. And that is going to be under Edit, Project Settings. I'm just going to dock this up here. And there should be under Engine Input. So this is a Project Settings, the Engine piece, Input. So it's still here for legacy reasons, but they are now depreciated. So this is one of your answers. Epic has made a new system. Go use that instead of this. And this is important because there are tons of tutorials that are still up on Epic's website in their documentation that refer to this system. So first thing you've got to do is translate what they want you to do here to the new input system. All right, this input system has two action mappings. Has two mapping types: action mappings and axis mappings. And that basically this is button mappings, axis mappings. So this is the booleans, and this is basically your floats. All right. And I'm just gonna I'll just add one just for the sake of showing you. So here is new axis mapping. What is the key? Yeah, what is its name? What bind is it? So this is with Epic. They've got a nice, good system where you can go. I can press that and it'll be G. I can go and do other types. So they've got Xbox One, and you can go specifically with Xbox One stuff. But gamepad, keyboard, mouse are the ones you're going to be looking at. Touch control. So there's a couple other things here. But yeah, basically we're going to just trash this because I don't want this part of my project. Because this is legacy. This is not where we're going to go. All right. So this is the old system. When you see stuff related, looking at engine input and bindings like action and axis mappings, that's the old system. All right, let's take a look at the new input system. And there's actually when you create a folder, they actually created a folder here for input. And there are two pieces. We'll start with there are mappings, and there are actions. And basically, we've got a jump action, a look action, a mouse look, and a move action here. Regularly, and under there is a input folder here, section here, and there are 4 things. Don't worry about the force feedback stuff, but there's the input action, and ideally, and we use typically they're using IA to represent this is an input action as part of their name. So IA fire, for example, is something we're gonna just throw in. We're going to create. We can double click on it, and it basically you can say what is the action description. This is primary fire, so, for what we want. What is the value type? And this is again where they had booleans and other stuff. Now you've got, is it a boolean? Is it a float? One axis. So if we look at, grab a controller quickly. So the buttons, these are booleans. The triggers, these are going to effectively going to be a one-dimensional. They're just going to be a float because it's going to be 0 not depressed, 1 fully depressed. Any value in between is how far it has been depressed. Your axes 2Ds, think thumbsticks, but also the D-pad. D-pad you'll get a digital 1 or -1 off that, but it's a vector 2. Axis vector 3. I don't have an example. That would be like if we pulled out the VR headsets and we were playing with the controllers. Their position and their rotation would be represented in those vector 3s. Those are and those basically this is a unified system. So basically, you go to your actions, you set what the action type is, what the value is here. And then let's go let's save it. There we go. So Control Shift S will save everything. And then once you've got your actions, you can then go to your mappings. And we'll open up the mappings here, and then we got jump, move, look, and I'll add the IA fire. And that is, again, and that then we can then go and bind it to, let me see. So they've done the right thumbstick, and they've got, should be more. Okay, yeah. So we'll come back to mouse look for one moment. So they've done WSAD, up, down, left, right. And so this is the arrow keys, WSAD, and then the gamepad. Jump, they've done spacebar and the face button bottom. So for them, they mean these are the face buttons they talk about. So they're generalizing basically these 4 buttons because they're different for each platform. Unity calls them north, south, east, west. So those of you in that class, that's how they're being called over in Unity. These are being called face button bottom. So for us, we're going to just basically do spacebar. Wait a second, no, not spacebar. They did that on the jump. I'll just do control, left control for our purposes right now. In theory, I should set up more, but I'm just for generic purposes trying to show you what you need to do. Now, I've gone into the default mapping, so this is the one that generally gets added. Now, one of the things that Unreal is doing is that they've complicated things a little bit. They've added another mapping. So if you're using mouse look, there's another mapping here just for mouse look, and they're getting the X, Y, 2D axis. So your mouse movement, X, Y is a 2D vector, and they're using that and applying that. How this all works, if we go to, let me see, where's the third person? There we go. So here is the blueprints. And here's the third person character. So effectively right now, Unreal is setting up movement based on the character type. That's not necessarily always the case. In theory, so in behind the scenes, your player, so there's a player controller class that represents you as the player. And that class underneath the hood is where the input is getting its information. That's where input is being generated from. But as the player controller, every frame, it gets its input. The player controller passes that input to the pawn that it is controlling. And right now, for one of the things that's happened since Unreal Engine 3 to Unreal Engine 4, one of the things that happens in Unreal Engine 4 is that code is now being written at the character level. So the character is basically saying to its controller, what is my input? When you ask for an input event, it is, in theory, it is reaching up to the player controller and getting that information for the data for the input. And this is done to make things simpler within the engine. Not always the case you want. There will be cases where there are things that the player controller has to handle. But you're not at a point where that matters at the moment. So right now this is where things are happening. It has been traditionally where the player controller passes information down to its pawn. Those who've taken older versions of the Unity, particularly game simulation, you've seen that in action. I know because Daniel's here. That framework does that, and that's because that represents an older version of Unreal Engine. But let's take a look at input specifically. And so, again, they've got event possessed. So based on that, they ask if what the new controller is a player controller. And if it is, they cast to player controller because this new controller is just given an object reference. It's odd that this is just, the new controller is just an object reference and not a controller reference. So they basically are casting it to player controller. And if that's the case, they are adding the mouse. So if in this case, if this is a switch on string, so if it's Windows, it's adding the mouse look. If it's iOS and Android, they're doing they're adding a touch widget for information, and they're adding it to the screen. Otherwise, they're adding the mapping input. And this is the enhanced input player system. There should be another one. Is there? No. I know default is being added by the player controller, so that's why you're not seeing that here. But moving on, they've got their different events. Secondary thumbstick, primary thumbstick, jump start, jump end. So do jump start, jump end, do mouse look, do move. And so this is input for first person movement. We can go in and we can, again, I'm going to do this here, but in the future, you'll be creating a copy of this player controller. Not the player, this character, I should say. My apologies. Not player controller, it's a character. So in the future, I'll have to check. That might be something I might add to this lab instead of working in this. In fact, let's, and I've shown you how to do this already. So let's just go over that just quickly. Let me just close this for one moment. So this is the blueprint we want to copy. I'm just going to go in here. I'm just going to make a new folder. I'm just going to call this Lab 04. And I'm going to go back to my blueprints, and I'm just going to copy it, bring that here. It'll ask advanced copy here. You should be able to just do a copy here. I don't think there's anything, because this is like dependent for folders and dependencies. But a copy here should be what we need. We can go in, and we will just rename this BP Lab 04 Pawn. So anything I need to do for Lab 4, I can do and not worry about ISO and not worry about how to do this. The other way we can do this, and this is another way, is we can go right click here and create a child blueprint class. And this is going to be BP Lab 04 Pawn Child. Let me grab that and put that into the Lab 4 folder. So and I'm going to just move here. So in this case, this is a full copy of that class. So if we want to go in and muck with all what's there, we can. With Pawn 04 Child, basically we inherited from that other class, and so we can now add things to. So we're going to add to the class, and so one is: do we want to have a copy of everything that we had previously, or do we want to inherit from that previous class and just add what we want on top of it? And so, for example, I'm just going to show you in this case. If I go to the event graph, there's nothing else here. It's like an empty class, effectively. So, I'm just going to go down here, and I am going to do. I'm going to type IA fire, and you can see there is enhance action events, and this is an arrow and a diamond. IA fire. That's what we want. We're going to open this up, and so because that will show us all of everything that's here. So the big one is triggered when this is triggered. Triggered is not always what we want. We can be more specified, and we can say, is it when it started? Is it ongoing? So we're holding it down. So this is for those of you. For those who are Unity, that's has been pressed, is pressed. Cancel, basically, for our purposes, completed is when has been released. Cancel, this is something like if the UI, like Windows, decides to interrupt the application. That would be a cancel situation. Action value, basically, it's a Boolean. Now, this is not going to be relevant for us right now, because if it's been triggered, then we know the action value is going to be a true. Now, if it was a float, that would be more. That was where you would get the value being from 0 to 1. elapsed seconds, triggered seconds. This is your delta times and input action. The input action that caused the event to fire. Rarely do I need to go grab the input action, if ever. But basically, I'm going to go off and I'm going to say started, and I'm going to do a print. And I'll go bam, bam, bam. And I'm just doing that because I don't know. Writing fired is boring. So I'm going to write something a little more interesting for our purposes right now. So I'm going to compile this. I'm going to go back to my third person level. I am going to file, I'm going to save this level, this different level, current level as, and that'll allow me to jump into lab 04, and I'll do this lab 04. I'm going to go to my world settings, and again, I already got the third person game mode right here already. I'm just going to change this to the 04 pawn child. So we'll start there. And we'll save everything. And if you when I hit, so you can see my input is working. So that number one first thing, is your input working? Because things will happen in this engine and fail, and you won't understand why. First thing you do for that bug checking is, hey, does my input work? Yes, it is for our purposes right now. All right, I'm gonna just go over to I'm gonna go to the other pawn, and we'll just show you again right here. Here's everything that class was setting up. Again, I can go in and I can do IA fire. If you don't know, that is a Scarface reference. It's quoted very often. So I'm going to compile. So in this case, in the other class, I'm going to make sure I save everything. I'm going to go to, and it'll be pawn for, or lab 04 pawn is the class that I just did that work in. And I will go and I'll play, and you can see that I've switched the class. So again, functionally, they are two different classes, but underneath the hood, the only difference is that one says one thing and the other one says another. Two ways to do the same thing. Sometimes you just, maybe, this is using the inheritance. I'm inheriting off the template character. This is a copy of it. Now the parent class is BP third person character. So this is showing you the inheritance we're dealing with at the moment. Showing the content browser. Again, this class is getting inheriting. Oh, okay. I think I've got these. Oh, sorry. This is the one that inherits from the Blueprint class. This one is inheriting off of a C++ class, because this is a template I built with the C++. But like, if we go look at, we'll just bring up. If I click on this, this will show that this is inheriting from another C++ class, which is the character C+ version of the class. Whether a class is generated in C++ or it's generated in Blueprint, you can inherit from it. A class is a class. That's one of the things, particularly with Unreal Engine 5. A class is a class. Doesn't matter if it's Blueprint or if it's a Unreal C++ class. You can make a Blueprint class off of it. You can extend it. And that's one of the things, I'm seeding this idea later on, because you will use this in practice. It'll be something that you'll use, and one of the things is you can write code generic to a class, and then have children off of that class that do that do specific things or radically different things. This is how you can make your code easy to use. But we'll get there. So I'm just seeding you the idea that you can do this. We'll get there at some point. All right. Let me just check, make sure I've gotten. Yeah, what's something the enhanced input system allow input binding system doesn't? And that's the answer is in the action. It's the mapping. Let me go back to the input. It's in these mapping. You can have multiple mappings. You can change mappings. You can remove a mapping. You can add a mapping depending on your situation. You can. This is one of those. I haven't seen a production game. I'm not sure how they're handling the action mappings. Typically, right now, you can just basically pile everything into the the default mapping. That's how that's the old school thinking of thinking. But the Epic has shown that you can add a mapping based on context. You pick up a weapon, there's a new mapping that's for the mapping controls for the weapon. Like for example, in the first person template, when you pick up a weapon, you are added a new mapping that is the firing actions for the weapon. So it's one of those. It's a cool feature, but I don't know how it's being picked up in the industry outside of Epic. So it's one of those. I just don't know the answer on that at the moment. But you can do that. It's not a big deal. But it's if you're not comfortable with adding mappings on the fly, then just put it into make sure you get into this default and you'll be fine. In fact, that's the technique we're going to do in this class for right now. We're not going to worry about these other mappings. So, all right. So let's take a look at so there's 3 exercises, which I should have. Let's just go over these quickly, what you're expected to do. And then we're going to go over slides that will help us explain. So in this exercise, you'll create a level creating 3 characters that can be possessed by the player controller using the 1, 2, and 3 keys. We'll put a point in here for a moment. May not necessarily be the player controller. This could be the player character that we're using. So based on when you are possessed. Again, there are create a map. So it's talking about you can do this. So there's exercise 1, 2. You can do the 3 exercises in its own map. Is what it's saying. Where we're looking here. Where is it? Okay, so this is asking you to do this in the level blueprint. Let me see. Yeah. So what they're asking here. So let's go to here. So let's go to the level blueprint, open level blueprint, and what they're saying is there is the one. Here it is keyboard events. Here's the 1 key. So when pressed, so what they're doing here is that so we're getting our event. So there'll be the 1 key, the 2 key, 3 key, variables. So for our purposes, we are So for this lab, let's go back to the lab 4. Pick one of these ways to do your work. I'm going to go with the lab 04 pawn child for our purposes right now. And I'm going to go to the level. So what they're saying is basically, and I probably want to maybe make a new level. I'm using this level right now, but in theory you could create a new level. Again, file, new level, basic. And actually let's just create that. Let's go with that. Save selected. And this is what we're talking about, is you can build what you want in here. In fact, you probably should. Just know for game override, make sure you do the third person game mode. and then set the pawn as we see fit. So our purpose is we're going to use the pawn child. And I'm going to just file save as lab 4A. This is because I've got another file already. So, and I'm going to, for our purposes, we're going to drag instance of that character into the level. And I'm going to leave this right here so I can see it. One thing you can do is you can go in and go into your starter content, particularly the materials again. And I'm going to make this one make him grassy. So here's my green guy effectively. I'm using the materials that are there. If you want to make a material yourself, go right ahead. No big deal. So when I press play, you can see that there are two characters in here. So the goal of this assignment is it's going to take this character here. We're going to transfer our control of the character that we have right now and take over green guy. And that's pretty simple. Let's go to let me close these. I don't need these open at the moment. We'll save everything, just do the safe side. So we're going to do this in the level, and so we're going to so I want to have this selected because I'm going to select, use that. I'm going to go to the open level blueprint, and I'm going to bring that up here. I want to create a reference to this because we'll use that in one moment. Do one key and then again down keyboard events. And so when this is pressed, I'm going to use the possess. No, that's not what I want. Let's start here. Let's get player controller. And it's going to ask for a player index, so 0 is the first player. And then I'm going to go off of here, grab it. There we go. Here's the possess function. And so when it's possessed, what I'm going to do is I'm going to grab, so lab 04 pawn child. We'll rename this. So let's compile. Let's go back to the level, and let's just, for sake of sanity, there is the rename. Let's go to details. Edit. There we go. It's under the edit tab. This tab now. F2 is the hotkey. So rename. For our purposes, this is going to be player pawn 1. And so, hooray! We now have that's been renamed. We go to the blueprint. You can see. Let's delete that. And let's go just for a sake of argument. Create a new reference. There we go. So one of the things it was asking to do in the editor was to go to variables. And we'll do, this is player. Let's just call it player 1. And then it's asking you to change its type. So we can change the type here. again, here are the basic ones you're going to be, the common you'll use on a regular basis. But we can go into BP underscore lab 04, and we're using the pawn child class. So we can, and the other thing is you can then click right here. This is a closed eye. We make this open. It makes it edible. And that's basically, it's clicking on instance editable. In an easier way to understand this, we made this variable public to, we can edit it in the editor. We can edit it in, we edit in the editor and other things can see it. So we can actually not, we can take this out. We can actually bring in get player one. The other thing that we want to do here is I'll make another variable of that type. And I'm going to do player spawned. We'll make this visible. And, so this is going to be again, we're going to get the player controller. We're not going to use tick. This is going to be off of begin play. So get player controller. And this should be get controlled pawn. So basically what we're going to do is we're going to set, and then we're going to plug that in there, and then we can plug that in there. Okay, this is acting weird. So again, it's giving this a pawn object reference, and this is going to be the pawn child reference. What we need to do here is what's called casting. So this is cast. BP, not what we wanted. And is again, lab 40 pawn child. So basically it is, hey, if that's okay, if it casts successfully, goes off here. If it casts failed, then there's a way to account for that. If this cast failed, then actually I'm just going to do print. And I'm just going to put in that print here just for the sake of argument. And I'm going to connect the output here to here, which is what we wanted. So this is going to be, you will get, when you ask for things like the player controller, for the pawn classes, they may be in a generic parent class. One of the things that you can do, with objects is that when you inherit, the child classes are valid references of the parent class. Problem is when you get a reference object in one of the parent classes, you then have to cast it from the parent class to one of the child classes to transform the reference that you need. And the reason is that if you've got a reference of the parent class, it doesn't have any idea of any of the functionality the child class can do. And in our case, basically, we're going back, all the way to pawn, and pawn has no idea how to do input. In fact, the character classes that we get are, character doesn't have any idea how to do input. Those are implemented in another class, which we have inherited from, if we copied that we've been inheriting from, if we copied or inherited again from that other blueprint class. So this is how code reuse happens in object-oriented systems. So, but the idea here is that we want to be able to, set this player spawn variable. Now I've made it public. I've made it instance editable, and it's public, but it doesn't really need to be. Let's just jump down here. I'm just going to do the inverse of this. So I'm going to do the 0 key. I'm going to grab these two nodes and I'm going to copy them because that's functionally what we're doing. So 0 key is pressed, and I'm going to get the player spawn and plug that in. So let's compile. Let's jump back in here. We'll press play. Is it not taking code? Oh, it's not happening because where is it's not happening because if we go to my output log, should be an error log. Should be yelling about that. Pawn number 1 is not being assigned. It's under world settings. I'll be honest with you, I wouldn't be doing this in the world. I actually wouldn't be doing this in the I'm going to go back to the other version where I'm going to take this and I'm going to, in our version, I'm going to go create a reference here. I'm going to have to take a look at I'm going to have to look at that. I'll be honest with you, I would have built this as a entity that I drop into the world and basically my pawn. If we don't do that this week, one of the things that we'll do, what will have happen is we'll look at that where you might rebuild this. But basically, I'm going to just basically refer to the pawn that's in the world. So I can take this out. Compile. Yeah, there we go. So I didn't have a reference to the object because I didn't set it in the editor, and I'm not sure the best way to set that. So here we go, and then I can hit 0 and I'm back to my plain white mannequin. This is one way to do it. Another way to do this would I would actually have built. So the way that I would have built this is that I would have instead made an entity that I put in the world that holds the robots basically, and that's how you would do that in a more efficient way. That way you could actually set player 1, player 2, player 3 that are in the world. That object would then get, it would ask for the player controller to, give me the object that was spawned in with you. And that's the big thing is that. The first one asks, can you go between the 3 of them? And then the next step is, can you get back to the one that was spawned into the world? So some weird things do happen. So when you are in the air, you don't fall. So, all right, that's basically the work that we're looking to do. Yeah, so I'm showing you in here basically 1, 2, and 3. I'm actually using references in the level. So. Okay, so that's your first exercise. Your next exercise. Why is this? No. We're not doing this exercise. It's too early. I'm gonna back you off on this. Hold on. Yeah, we're not doing exercise 2. Let me take this out. It's asking you to do some HUD stuff, and I don't want to throw the HUD at you right now. There's a whole lecture on just the HUD. and it's using the HUD in a way that I don't want you to. It's basically using the HUD in a way that's not really appropriate anymore. I want you'll see what that is talking about in that lecture. We'll touch on it briefly, what those nodes what you can do with the HUD, but ultimately the HUD is actually built modularly through widgets, and I'd rather just teach you that than to show you this old style that you're never going to actually use in practice. All right, you're going to create an actor that's going to move across an array of actors in the scene. So I'm going to go over what's going on. There's 2 actors that you're going to create. And for our purposes, let's go into, it's going to be the path point and the path runner. So let's go back to our lab 4. So you're going to create a new blueprint class. It'll be of type actor. And this is going to be, the first one we'll do is BP path point. Path point BP or PP path, your choice. I'm going with the preference first. All right, the path point. This is really simple. Pick a shape. I'm gonna go with a cone today. But I've done cube, I've done spheres. I'm just gonna do a cone because it's gonna stand out. I'm going to, so the big thing that we're dealing with right now, make sure we are in world coordinates. Let's move this up. Let's make this smaller, by the way. Let's do 0.5, 0.5, 0.5. Yeah, that should work. 50? No, 25. There we go. So basically, I want the root of the cone to be it's where I want, and then I'm going to go to here, and just scroll through. I'm just going to use the text hex pulse because let's have fun. I would have used a red texture basically, or a purple texture, and we can go and create a material if you want. But basically, I want something that stands out. I'm going to compile this. All right. So with this cone, the cone basically, the cone has the visual component. Else, what we want to make, so the first thing I'm going to do is I'm going to go look at its under collision. Basically, I'm going to start with set it to no collision. So this is not something that in terms of game setting, it's just a marker in our world. So we don't want any collision on this. That's the first thing I'm going to do. The other thing is there's a setting called view. Type in game. So under rendering, there's again, it's hidden in game. I'm going to turn that on. So when we're playing the game, this is an entity that is not shown to the player. I'm going to keep this on for right now. We're going to turn it off because it will make it easier to debug things later on. Let me just compile. Let's jump back to our world. And I'm just going to put in, here's my path point. And there we go. I've got my path point. And it's snapped to the world, which is what I wanted to do. All right, I'm just gonna copy and paste. So I've got, basically I'm gonna do 4 right now. And I'll make a box out of these. I'll make a bigger box. Now. And I move 3 at the same time. There we go. So basically I've got these 4 points. They're going to basically I'm going to go from this point to this point to that point, and come back. In fact, I'm going to make a new folder. I'm going to call them path points. and drop them all in here so they're out of the way. So we'll come back to this in one moment. Again, the other entity is going to be, again, another blueprint class. And it's going to be an actor, so it's not a pawn. It's not something we're possessing and we're going to grab input on. It's just going to act, or it's going to act on its own. And we'll call this BP path runner. All right. I'm going to jump in here. I'm going to add a. I'll use this. Yeah, I'll use a cylinder. And I'll make this 100 size of 2. And just for the sake of argument, I'm going to copy and paste the cylinder. So we have a second cylinder. I'm going to move this up forward just 25. And I'm going to make this one 0.5, 0.5. And I'll do 0.1. Not 0.1, just 1. I probably need to do 50. So just so I have that little nub, so I have an idea which way I'm facing forward. I'll grab both of these and I'll just grab the material. And I'll make this one, I'll use gold again. Just so we have something to look at. So it's not. I'm going to compile this. We'll come back to this in one moment. There'll be more work that we need to do in here. Let's go over. So before we do this in entirety, I've got some slides to go over with you, so it makes sense. Talk about Quiz 4. This is talking about the gameplay frameworks one more time. I think I've given you these slides before. Yeah, so I'm gonna just skip over these. We went over these last week. So advanced blueprint concepts. All right, arrays. This is the first one. So when you create a type, there is another. So basically you can tell it what type it is. There's another button next to it. Let me go back to. Let me actually just jump. So what they're asking here in terms of variables, we're going to create a variable and we're going to call it path point. Make this a little bit bigger so we can see it fully. We're going to go to Boolean. And it is going to be of, we can do a type actor. We can be more specific, BP path point. And we'll actually use the path point here. So basically, it will. So right now, this variable will only take an instance of a single path point right now. What we're looking for is right here, is this button right here. We can pull this down. We can create an array. We can create a set, a map. We'll worry about sets and maps later on, but the array is the one that we're most concerned about. So now this can take multiple path points. For those who are from Unity, the list is the equivalent of what we're doing here. Let's compile, and then let's go into our map, and we'll actually put a path runner in the world. I'll put him over here for the sake of argument. We go to him, go to details, and under should be a default section. What I didn't do is I need to make this instance editable. And I need to compile. So now that I've done that, it's now showing under the default. Now it's showing default here because we haven't given it a category. And you should be setting categories. So here's the category. And I'm going to go here and kind of type path runner. And you can see there's now a section here for path runner. I can collapse the components. So now if when I compile and go back, you'll see that there's now a category path runner and path point is here. I can add 4 elements and assign them. Oop, I need to select the path runner one more time. There's a lock button right here, so it just locks the current panel. So when I click around in here, this is not jumping around. And I can just go and just assign the path points right here. Pretty straightforward. So now my object knows those 4 points in the world. And I can now do things with that instance of that in the world. So when if you're spawning things in and you need reference to things, that's when you will create basically a actor that's going to hold data, where you can put that in the world, so it's level specific, and then basically it goes off, and basically the level you can then assign that information in that actor. And then the other actor that spawns in can then refer to that other class for information. So, advanced stuff that you may be doing later on, but right now this is this is important for what we're doing at the moment. Let's just jump in here. Yeah. So that's the thing. That's what it's an array. It's an ordered list. You get an index based on an integer-based index. The main nodes gets at a particular index, and you can plug. This is the array that you'll plug in, and down here is the index you want, or you can give it a number. Length. How big is the array? For our purposes, the length array is 4. Thing I need to be clear about is that the first element in the array is 0. The last element is n minus 1. So since we are right now playing with an array of 4 with the path nodes that we're playing with, the last element would be 3. If we had 15 path points, first element is still 0. Last one would be 14 in that case. If we wanted to do 100 path points, which is possible, first element would be 0. Last element would be 99. We can add on the fly, and we can insert at a particular point. So this is changing the array. We can change the array. This will add at the end. This is typically normally what you'd be doing. Insert is you're inserting at a particular point. A good example of insert would be I've been playing Roadcraft, and one of the mechanics is that you build infrastructure routes. Basically, you're putting down path points, and you can insert path points on that as you need to. And that would be an example of insert. You insert in front. So if I've got five nodes right now, and I insert, let me see, I insert at 3. 3 becomes 4. 4 becomes 5. I now have 6 elements in the array. So. Sets, they're like, I'm going to go over this briefly. Similar array, but unlike array, it's an unordered list, and lists are search-based. You search them based on your value. There's no index. You use as you see fit. And then maps. Basically, the idea with a map is that there is a key value, and then there is there's a key, and then there's a value, effectively. So in this case, they're showing basically an integer and then a string that is mapped to that integer. So you give it a 26, you get health. You give it a 38, you get the string life. You get a string 43, you get money. You have a string 54, and you get shield. Use sparingly as you see fit. More often the array is what you want than a map. There is also dictionaries. This is what the map kind of is emulating. And there's also enums. So if you were didn't really want a map variable and just wanted these to be states, you'd use a variable type called enum, which we'll talk about later on. But these are the variable types you can change. Again, sets and maps, you're not going to use very often, but arrays you will. Structures can use to gather. So this is the idea behind a structure is that you can gather up multiple data types into one type. So you can create. So like the vector 3 is a structure. Vector 2 is a structure. They hold an x and a y, and the vector 3 has the z. Here's a structure. Basically, it's a new it is the new variable, the name that you're going to call it. And this is name, and this is the type that it is. Amount, it's an integer. Image, it's some sort of texture. So, we'll talk about structures later on. It's not something you're going to be using on a regular basis, unless you're doing higher level like application building or systems engineering. You'll use the structure then. But for our purposes right now, for general gameplay purposes, you'll use established structures, and you're not necessarily creating them. But I just want to make sure you can create structures. Again, here is an example. Is an example of items. So name, amount, image. Break and make notes, and this is something that you've been using already. I've shown you that, like, hey, the transform is a structure that holds 3 other structures, and we can conversely then break those structures into their components, which is the x, y, z, for the location, for the rotation, and for the scale. Again, get actor location. Here's return value x, y, z, which I just showed you. Enumerations, which I just talked about. This is creating a new variable type that consists of specific values. And we'll talk about enumerations a couple times later on. And right now they're going through shock rifle, flat cannon, rocket launcher. Those are under this enumerator they're creating. They're right now enumerating the old weapons of Unreal Tournament. Not how you would do this. This is which current weapon equals this enumerator variable is not how you go about doing that. So I'll just tell you right now. Enumerators you should know about, but it's not something you're going to be using on a regular basis, and you'll use them sparingly. And we'll talk more. That's something we'll talk more about later on. We will use the enumeration to control an application state later on. That's one of the things that we'll use it for. And I'm not going to go over this. The one thing that you can switch based on the weapon. So here, weapon type. Here is they're setting a static mesh. Weapon mesh is equal to whatever this mesh is. This is not how you would go about using the enumeration and how you use. This is how you use switch. Right now this enumeration of weapon type has three values. So this is, yeah. So I just it's an interesting way to use the switch. Not how you would actually use it in a production setting. Just showing you a way to use this. This is how the switch works. Data tables. Think of old school RPGs. The other game. Let me bring up. I need to find it. So in Starfleet Battles, there is a game. So here is the Enterprise, effectively. It's a heavy Federation cruiser. These are the data tables we're talking about. This is your die roll and how far you are and how much. This is how much damage you do. So the phaser 1, phaser 3, photon torpedoes. And there's all sorts of other data things here. And this is Highly complicated for this is a so Starfleet Battles is a game from the 70s that was a beer and pretzel style game. It's long, it's complicated, there's a lot going on. BattleTech was described as a beer and pretzel game to replace that. That's long and complicated as well. So yeah, what is considered a beer and pretzel game now is different from what it was 50 years ago. But here is, if you're looking for a data table, this is what we're talking about. It's data like this. Here's the Phaser 1 data table. Here's the Phaser 2 data table. So if your game has stuff like that, this is stuff. We talk about D&D, a loot table that gives out that this table has specific items that you could get. That's a data table. So just jump back in. Again, here's the data table. Get the row found, row not found, out row, and that's giving you a structure of the values that are in that row. So. Latent function delay. So basically, this is spawn enemy. This will delay. So you'll wait X number of seconds, and then it'll do what you'll want. So this is just basically delay function performs action after the completed pin, only after time specified has been elapsed. So this is an event called spawn enemy. It gets called, it delays, and then it spawns the enemy. So, and there's a duration here you can plug in, which is the float. Retrigger delay, you can give, again, this is a latent function. So this will retrigger. So if you wanted like so one thing you could use this for is like, hey, every second I'm adding something to the world. So duration would be 1, or let's say 3 seconds. I'll add something to the display. I'll add something to the world. I'll do this and call the spawn function. Spawn function figures out where it needs to spawn and puts it in the world. Timer, you should have seen this already from the previous lab. You can set timer by event. So you can set it also by function. So we used the function name last time. Yeah, we'll I know last week we had a timer that every second it was doing something. Through we were setting a clock, and every second it was doing something every second. And I know at some point this week we would have put that to the screen. Don't want to show you that method right now because it's not. It goes to the HUD class. I don't want to introduce the HUD class right now, to be quite honest. And I don't want you to use basically they were writing strings to the screen, and that's not how you would actually build anything properly. So we have a whole lecture and lab based on that, how to do things properly. So we're actually going to go back. That I need to go back and look at that lab one more time now. Now I know I've pulled this out. So don't worry about putting things onto the screen. Those references I'll be pulling those from the labs for right now until we get to that. Again, it's like a couple weeks from now, so don't worry. We will get there. It's just I want to show you how to do it the right way, the way that it's intended to do it, and not this hacky way that is old. It's referencing an old technique that you would have done like in Unreal Engine 3, 5, and sooner. Late engine, even with Unreal Engine when Unreal Engine 4. These widgets were in play already, so I'd rather use the widgets and not use this old style that's really a debug purpose. Loading levels, so you can load different. You can change your levels. So a main menu. So one of the big things is we can create a main menu that is its own level, and then we can go to another level that starts what we are doing. And then you can quit the game. All right. saving loading data, save game blueprint. Well, I'm gonna skip this for right now. You can come back and look at it later on, but you can save your game. You can create a same game object. Save the game slot. So I'm gonna leave that alone for right now. Now let's talk about. We talked about the actors. All right. So the goal of this lecture, we're going to talk about transform world coordinates, local coordinates, relative and world coordinates. So transform, again, we've talked about has a location, rotation, and scale. I know this is using the older engine, but we basically, let's just jump back to Unreal just quickly. So what they're talking about in terms of switching between world and local is up here. So I can go in world space or I can work in local space. And again, the goal, with local space, if I rotate the object, you see that it's in local space. The forward vector is represented by the object's rotation. And that's the big difference between local and world, is that it's forward, references to forward, left, and right, and up are going to be referenced based on the object's rotation. And that reflects, if I had parented stuff, it will reflect the parent's rotation as well. That in our path runner, so these cylinders, again, these forward rotations, right now, again, we're looking at them in the local rotation. They just happen to be lined up with the world rotation as well. So this forward vector will be, again, here's the object in particular will be used. But basically, these forward rotations will be represented by the object rotation, the instance of the object. So we'll take that to an effect. Talked about the world coordinates, again, X, Y, Z in the world, again, local. Location functions, get actor location, set actor location, add actor world offset. You're better off using get and set as opposed to get world offset. Like this is, you can do the delta location, you can do that work, you can do that. I just find get and set are more meaningful. But this is here, Epic's made this for you. Relative transformation, again, we've talked about this. This is so again, we've got two objects here. We've got the base, which is the root component, and then the power pill, which is a child of that. And we can move this pill bounce up and down based on its relative location. So right now, relative location of the power pill component are at 0, 0, and 70. Relative transform locations, again, this is off the reference of the power pill. We can get its relative location. You can get its world location. You can set its relative location, and you can also set world location. Points and vectors. So a idea is that a vector is a structure that contains, again, we talked about X, Y, Z. A point in space is represented by a vector 3. A point on your HUD and on your screen, like the UI, is a vector 2. It's a 2D. It's a 2D. So it only has an X and Y value. And these are floats. I know we're looking at them as whole numbers, but they really are floats. It's really not 300 centimeters. It's 300.0 centimeters. It's a float. Vector addition. So here we're looking at a vector that is 5, 9, and we're adding 1, 2, 3, 4. 4, 2 is the other vector. So 0, 5, 0, 9, 4, 0, 2. We add them together, 5. So we add the first two values together. We add the second two values, the y together, and that gives us 9, 11. Again, this is we can add the blueprint here in this way. I mean, we can add them in blueprint using an addition node. So that's the thing, is you can add vectors together. You can subtract vectors. In this case, this is our first vector is 12, 14 up here. We are subtracting 4, 8, and that gives us the value 8, 6. 806, I should say. I'm skipping the y up for some reason. I don't know why they're using the z and the x instead of the y, but this is the example they're showing. Length of a vector. So a vector holds two pieces of information. If we look at here, a vector has a direction. So this case, this is from here to end. Here is the direction. From here down here is that second vector. This is the other direction. When we subtracted these together, it gave us this vector here, where it represents a new vector with that direction. This is important, that the idea that we can, we'll come back to this in one moment in terms of application. But that's the first thing. A vector has a direction. There's one vector that we have to note. It's the 0 vector, the 0, 0, 0. It does not have a direction because it's 0 across the boards. And you should that's the one thing you should know. It's the one caveat in all of this. In rotations, we're using vector 3s when we're using Euler vectors. And when we get close to 0 or at 0, there's what's called the Euler lock, which means it can't rotate because you're dealing with a 0. How is that solved? We move to a vector 4 with quaternions and vector math. There's a different meaning for vector math and mathematics, and it's a lot of math that we don't need to go over right now. But just know that underneath the hood, they're using a vector 4 for rotations for purposes. Don't worry about it. We have established how to go from the quaternion back to the Eulers and Eulers back to quaternion easily back and forth. So you don't need to know the underlying of how it's being structured. You can use Eulers as you see fit. In our case, the 1204 would have been plugged in here first, and then the 408 would have been plugged in second. So this is the A. This is the A minus B. First vector minus second vector. If we have done 408 minus 1204, our answer would have been it would have been a -8, 0, -6. So order operations matters with subtraction. Go. Don't even ask. Just go. Length of vector. So the other component of a vector is that it has a length. So basically the answer is, if we're dealing with a square root, so with a vector 2, it's a square root of x squared plus y squared. In a vector 3, the length is the square root of x squared plus y squared plus z squared. So this is why if we have a vector that goes from 0, 0 to 1, 1, that's a length of, so that's 1 squared plus 1 squared, which gives us 1 plus 1 is 2, and the square root of that, square root of 2, is our answer. That is equivalent to about 1.7. So that's why if you just go off in a diagonal and you don't account for things, because you've gone off in a diagonal, if you're not paying attention, you can move faster if you're not accounting for that. We'll talk about how to handle that in one moment. But let's move on. The distance between two objects. We can calculate the distance between two objects. So again, up here we looked at points in vector, and it's saying this is 300 across. Let's just assume, for our purposes right now, the chair is at 0, 0, 0. That must means that this table, again, we're down the x-axis. We're going to assume, because this is the red arrow, we're down the x-axis. So the position of that table would be 300, 0, 0. Now this is really small stuff if this is 300 centimeters. This would more likely be 3,000 units than opposed to 300, given how Unreal uses their math how big things are. I would assume this is 3,000, not 300. But again, both the direction and distance can be gathered in the vector 300, 0, 0. So again, this is the direction. So this value 300, 0, 0 is relative to the 0, 0 position here of this chair. But what if we're somewhere else in the world? Let's say this is let's say for the argument, let's say the chair is at 1,000, 0, so it's not elevated. The table in this case would be 1,300, 1,000, because we're adding 300 on the x-axis, so this is the 300, 0, 0. We'd be adding that to the 1,000, 1,000, 0, and that would give us the 1,300, 1,000, 0 vector. That would be relevant. So that's how we would get that. Now, if we know the chair, if we wanted to know the direction and the distance from the chair, if we knew, so let's just, again, I'm going to use the values 1, 2, 3, and 4, 5, 6 for ease of use right now. Let's assume the chair is at 1, 2, 3, and the table is at 4, 5, 6. The way that we figure that out, the direction and the length of that vector, is we take the length, we find, so let's refer to the table as A and the table as B. We subtract B minus A. Where we want to go minus where we are at is essentially is the answer there. And I know there'll be a slide that'll go over this in one moment, and it'll be, but basically we subtract where we want to go minus where we are at. So 4, 5, 6 minus 1, 2, 3. That's going to give us 2, 4, and 6. Is it? No. Wait a second. Let me write this down. 4, 5, 1, 2, 3. Actually, the answer is going to be 3, 3, 3. Let's do another example. So this is going to be B, A. Again, let's B again in this example. B is our table, and A is our chair. So B minus A is chair to the table. So B, we said we wanted to be, say, hey, 3,000, 1,000, 0, and the table is going to be 1,000, 1,000, 0. We subtract these, the answer ends up being 300, 0, 0. The x ends up being 1,300 minus 1,000. Y ends up being 1,000 minus 1,000, and the x ends up being 0 minus 0. So we know the direction. This is the length. We know by virtue of this vector being only on the x-axis that it's 300 units. Let's take, we'll do, so we are, where we're going is 1, 1, 0, and we'll start from the origin 0, 0. We know that the answer is going to be 1, 1, 0. So any time that you are starting from an origin value, so we can represent a vector from a 0, 0 point that's relative to something. So right now we're assuming that let's say we're talking about, let's say that we're working more like in Unity. The answer here again is going to be the square root of 2. if we have another, and this is, I'm using numbers I know, 4, 5, is it 5? Yes, 5. No, it's 4 and 3. And I know just by, this is because I know the math behind this scenario. This ends up being 4, it's going to be 4, where is it? 2, 3. So I know that this ends up being 16 and 9, and that's equal to 25. Square root of 25 is 5. So the vector 4, 3, 0 has a length of 5. Okay, so now we know how to get the length of a vector. We know how to, we know that the director is represented. When we want to, it is not always useful to have our vector at a length beyond length of 5. Let's say 4, 3 is my directional vector that I got. If I wanted to move on that particular, on that direction, but I'm going to have to recalculate the vector based on the length that I've got. And essentially, you're basically dividing by. So since we know that the 4, 3, 0 has a length of 5, if we divide by that length, so vector multiplication, so basically we can multiply and divide based on a single value. And so what that will end up being is 4 divided by 5. So 4, 3, 0 divided by 5 is going to be equal to 4 divided by 5, 3 divided by 5, and I'm just going to do 0. 0 divided by 5, which is 0. That will give us our vector. So we just normalize that vector. The idea is we're taking the vector and we're dividing it by its length to get a vector that is of length 1. And that's what we mean by normalizing. And we'll do this a lot. In fact, one of the things you'll use normalization this week because you're gonna know your position, you're gonna know your path points world position. You'll divide by that, by your normalizing. And that's effectively what's going on. So, excuse me. Excuse me. Okay. So again, we call that normalized vector a unit vector because it's a length of 1. If you draw a circle with a radius of 1, every point on that circle is a unit vector. You draw any line to that radius, it'll be a unit vector. And that's what we're doing. And again, this isn't really important to we only want to deal with, we want to keep the direction, but we want to throw out the length because we want to do something else with that length. So that's what normalizing the vector is. Scalar vector multiplication, basically we're multiplying a vector by another value. Again, move speed is going to be the one that you're going to be using this week. So you will calculate the vector from point A, from where you are to the path point. Then you'll normalize it. That'll be your actual movement direction, and then you'll multiply by your move speed, and then that'll be that multiplication is how much you actually are going to move per second, effectively. You'll multiply that again by time delta delta seconds, or time delta time for unity people, and that will basically move you relative to how long that tick has been. Dot product, it's used to verify relations between two vectors, whether they are perpendicular or parallel. So a dot product of one, they're moving in directly the same direction. A negative one, they are opposite to each other. So I'm moving down the x-axis 1, and I'm going up the A is moving down the axis of value of 1. B is moving down the x-axis of value of negative 1. That's a dot product negative 1. When you have a 0, you're at a 90-degree angle. So, and that's it is not often you'll be using the dot product, but you should know about it. We'll talk. We'll talk more about the dot product. It will sprinkle into things as you go along. Get forward actor vector. I mean, literally, you can just there's a node for actor forward vector. This is not how you would add. Well, I mean, this is basically world direction, scale value. This is some function that is adding that you'll write to add the forward movement. So you can get the right vector and you get the up vector. And again, these are, I believe, these are relative to the actor. So these are relative, not world this is not the world vector. This is its local relative vector that you're getting. So you can also set these. You should be able to set these vectors as well. But basically, again, this is the big thing. Let's go back to the blueprint fun. This is the description of B minus A, target point for the runner. You will get your actor location of the current point. So you'll have a variable what your current point is. And whatever path point you're moving towards will be set to that. The default screen route is where the runner is. You get its world location. And that is the B minus A that you need to know. And this is the what you'll then normalize and then multiply later on to do your movement. So this is your direction vector B minus A. Here is with use of functions, easier to realize than you realize. Here is path list. We will set the current path point to 0. And then we'll update our move direction. Here's a function that we'll write. Update move direction. So we'll set our move direction variable. Here we basically will have your intent. If you're active, we will move. If not, we won't do anything. And if on delta seconds, we'll move the runner. And then we'll check distance and update. So this is another node that we'll create. Where you basically sit down, check the distance. If it is, you'll move to. There'll be another. One of the functions you'll write is get next path. So you'll call that, and then you'll update. Again, you'll call this update move direction node again in here. And you'll be set up for your next go around. And that's the thing that you're going here is that we want to be set up for this is going to set up for our first tick. This is going to be our tick. And then if we need to change our direction, we'll do that here. Let's zoom this. So we created the path point. We've created our path runner. A slew of variables. Next path point, again, advances the path index by 1. If the index is length of array, reset to 0. Assigns the next point to the item, the array at the index. Set move direction, calculates the B minus A. Sets move direction using the V minus A. Breaks B minus A vector, so Z is 0. X and Y are changed. So we're not playing with the Z vector in this example. You can if you want to. You can if you want to play with the Z vector, but we're not necessarily playing with that right now. I am starting to run out of time. So Wednesday. Sorry. I will be creating another video, probably later tonight, where I go over the internal mechanics of the path runner. So like these functions and all that, so that you have that later tonight, so that you can do. So if those of you who want to work on this weekend, able to, but don't worry too much. I'll be going over this in Monday's classes as well, so don't worry. Again, move runner. It's basically this is the function that's actually going to set the new location of our object. So one of the things that we're doing is every tick we are moving this object. Those who've gone through the Unity classes, you've done this before. Now you're just doing it on Unreal. Check distance and update. Again, does do the b minus a calculation. Checks if b minus a is less than within the range variable, and if that's true, calls next path point and sets move direction. On begin play, sets current path point list. On tick, if it's true, then calls the move runner, passing delta selected to that function, and then calls check distance and update. And I've shown you the structure of it. It's the internal structure of these guys that I don't have enough time to talk about right now. So there'll be another video that I'll create later tonight. All right. Are there any questions before I stop the recording? All right. Yeah, I'm going to stop the recording here. I'm going to say, there'll be, again, I'm going to create another video later tonight. Again, I have so look forward for a second video just going over the internals of these functions. Again, why are we using functions? To make our lives easier.